Hello. We are going to discuss experimental probability today. So, some things that we want to remember with probability is that probability is the measure of the likelihood that a specific event will occur. Probabilities are going to have a value that are between 0 and 1. So, this is where we're going to be dealing with those decimal points or fractions. An event that is impossible is going to have a probability of 0, meaning there's no way it can happen. And then an event that is certain is going to have a probability of 1. So, for instance, if we take into consideration rolling a dice, if we're rolling a dice and we want to know what the probability of rolling the number 1 is, we know that there's one event that we want to occur, and then the total amount is 6. There's 6 sides to the dice, so it'd be 1/6. Now, an event that is impossible has a probability of 0. So thinking about that dice, we're rolling, um, we want to roll a number that's 10, but we know the dice is only labeled 1 through 6. We know that that's going to be impossible. There is no number 10 on our dice. And then if the event is certain to occur, this is going to have a probability of 1. So if we say, what is the probability of rolling a number that is between 1 and 6? That is certain to happen because that dice is labeled as 1 through 6. Now, when we look at experimental probability, that's where we are going to look for the event, and we're going to look for the number of times an event is going to occur over the number of total trials that we're trying. So instead of just doing it one time, now we're thinking about multiple times and how many times that event occurs. We want to make sure that we remember that probability can be written as fractions, decimals, or percents. So when we're looking at our practice today, we're going to look at all three. We're going to take those, the probability, get a fraction, and then we're going to change that fraction to a decimal, and then we're going to change that decimal to a percent. All right, so let's take a look at this first example that we have. Okay, so we looking the probability again is the probability of the event is the number of times that an event occurs over the number of total trials. So in this question, it says the band played an encore at 2 of its last 6 shows. What is the experimental probability that the band will play an encore at its next show? The first thing that we want to consider is what are we looking for? So we're looking for the probability of an encore. Okay. And that's going to be equal to the amount of encores that they have already done. So the number of times an event has occurred over the total of trials. So when we're thinking about this as a fraction, we want to first look at our numbers that we have here, which looking at this, they've already played an encore 2 of its last 6 shows. So we're going to take that information that we have, and that's how we're going to set up our fraction. Total amount of encores that we have had would be 2. They've played 2 encores, and then the total, we're talking about their last 6 shows. Okay. Now, in this case, we do have to reduce this fraction. We do have to have these fractions in simplest form. So we have to think about what number can we divide into both the numerator and the denominator to simplify it or reduce it. We could divide both the numerator and the denominator by 2, which would give us our answer as a fraction as 1/3. That is the probability of an encore occurring. Now, if we want to change this to a decimal, that is where we're going to have to take that numerator, so 1/3. So the number that's on top is 1. So we're going to take 1 and divide by the denominator, which was 3. Now we know that 3 cannot go into 1, so that's automatically going to be a 0. But then we want to add a decimal and we want to add some zeros. We're going to just add a couple zeros here. Okay, you might not use them all, but just add a couple. So then we're looking at, we want to bring up our decimal here. Okay, and then we're going to kind of forget about it inside the house. Okay. So now 3, we're looking at how many times does 3 go into 1? That was 0. So how many times does 3 go into 10? And we know that that's 3 times. So 3 times 3 is 9. And we subtract, we're left with 1. So we bring down our 0. How many times does 3 go into 10? 3 times. 3 times 3 is 9. Subtract, we're left with 1. We kind of see there's a pattern here, and we're going to keep getting that answer of 3. It's never going to reduce all the way down. So 3 times 3 is 9. We subtract and we get 1. Okay, which means that our decimal would be 0.3 repeating. Okay, we're never going to be able to take that decimal all the way down to nothing. So then a percent, what we want to do is we want to take this number, which we know this is 0.333 repeating, and I did add some additional threes because I know that it is a repeating number. But remember, with percents, we have to take this decimal and move it 2 places to the right. Okay, so that's going to tell us that our percent in this case would be 33. We could say 33.3, or we could round to the nearest whole number and we could say, okay, looking at this number past the decimal is a 3. Remember, if it's 5 or more, we're going to raise the score, which means we'd raise this number up. Or if it's 4 or less, we're going to let it rest. So in this case, we're just going to let this rest as 33%. So the amount of times, the experimental probability that the band will play an encore at its next show, we can say the fraction is 1/3, the decimal is 0.3 repeating, and the percent is 33%. Let's look at another example here. We're going to move to the next example. So this example, same thing, we're looking for our experimental probability. It says Brennan's Breakfast Goodies recently sold 20 muffins, of which 4 were pumpkin spice muffins. What is the experimental probability that the next muffin sold will be a pumpkin spice muffin? So that's what we need to figure out. And how do we do that? We're going to, the pumpkin probability of a pumpkin spice muffin is going to be the amount of pumpkin spice muffins over the total amount of muffins. So as we convert this to a fraction, we can say, okay, how many pumpkin spice muffins did we have? Okay, in this experiment, we could say there were 4 pumpkin spice muffins. And then how many did we have for a total? We could say they recently sold 20 muffins. So that's the total amount we're looking for. And now again, in this situation, we can reduce this fraction a little bit, simplify it by dividing a number into both the numerator and the denominator, which in this case, if you think about it, you can divide 2, but you can go even higher. You could say we can divide by 4. Divide the numerator and the denominator by 4, which would mean that 4 divided by 4 is 1 and 20 divided by 4 is 5. So our fraction in this case would be 1/5. 1/5, the experimental probability that the next muffin sold via pumpkin spice is 1/5. Now as a decimal, we're going to do the same thing. We want to take this fraction we have, 1/5. We want to divide the numerator by the denominator. Okay. We know that 5 cannot go into 1, so we would have this as a 0. And then what we need to do is we need to add our decimal and we need to add some zeros. We can bring up our decimal at this point and we can forget about it down here. And then we think about how many times does 5 go into 10? 5 can go into 10 2 times, and then 2 times 5 is 10. We'd be left with 0, which we did add an extra 0. If we brought that down, we would just get, 5 can't go into 0. We just get a 0 after the 2. So we can leave this as 0.2. Now as a percent, we're going to take this decimal here, and we have to move this decimal over 2 places. Okay, now in this case, moving it over 2 places, we have this blank spot. So we're going to add a placeholder of 0, which means that our percent will be 20%. So thinking about what is the experimental probability that the next muffin sold will be a pumpkin spice muffin, we could say as a fraction, it's 1/5, as a decimal, it's 0.2, or as a percent, it is 20%. All right, taking a look at the next question. Here we have this chart. It's set up a little bit differently, okay? But we're still going to do the same steps that we did before. Rebecca supplies costumes to a number of theater companies and recently lent out a number of different hats. We can see here there's turbans, berets, motorboards, top hats. Those are the hats that Rebecca has lent out as part of her supplies for costumes. We want to figure out what is the experimental probability that the next hat requested from Rebecca's inventory will be a turban. Okay. And so we have to think about, okay, so our experimental probability, and how are we going to set this up as a fraction, which that would be the type of hat that would be requested, which is a turban, and the total amount of hats that we have. Okay. So when we set this up, we want to think about, okay, how many turbans has she already lent out to other companies? Okay. And in that case, we can see that that number is 6. That would be our number in the numerator. Now, the denominator is going to be a little bit different because this is the total amount. So when we look at the total amount, there is no total amount of hats listed. So what we need to do is we need to take each one of these numbers and add them up. So we're going to say 6 plus 3 plus 3 plus 2. That's going to tell us what our total is. Okay. And the reason why is because this chart shows the total amount of hats she lent, but it's not set up to tell you how many hats there was that she did lend out. So you would just take those numbers, add them up to see how many total did she lend out. So that would give us an answer of 6, and then 6 plus 3 is 9, plus 3 more is going to give us 12, plus 2 more is 14. So we have 6 over 14. But now we need to simplify. Okay, so we have to think about what number can we divide into both the numerator and the denominator to reduce this. If we divide both the numerator and the denominator by 2, we would get a fraction of 2 goes into 6 3 times, and 2 goes into 14 7 times. This is going to be the fraction of how many turbans are lent out in this experimental probability. Now, decimals, we're going to take our 3/7 fraction. We're going to take 3 and divide by 7. We know that 7 cannot go into 3, so we would have a 0 there. But then what we're going to do is we're going to add a decimal and add a couple zeros at the end. And now we can bring up our decimal, forget about it here. So thinking about how many times does 7 go into 30, we can say, okay, 7 times 3 is 21, 7 times 4 is 28. So we could say 4 times 7 is 28. We subtract, we get 2. We're going to bring down our 0. 7 goes into 20 2 possible times. 2 times 7 is 14. And that would leave us with 6. And we could bring down this 0. 7 goes into 60. We would say 8 times. 8 times 7 is 56. And we'd be left with 4. Now, in this case, we're going to keep going. This decimal is going to be very long, okay? We want to make sure we read the instructions, and if the instructions say round the decimal to nearest tenths place, we're only going 1 place past the decimal. It says hundredths place, 2 places past the decimal. Thousandths place is 3 places past the decimal. So we could do one more where we bring down a 0. We could say, okay, this would be 5. 5 times 7 is 35. That would be 5 here, okay, and keep going. But we're going to stop here, and these 3 dots are going to indicate that it would keep going, okay? So we could say our decimal 0.4285. And then, of course, let's say we're rounding to the nearest thousandths place, we'll say. So 3 places past the decimal. And so we would look right here to this 5. And this 5 would tell us we're going to round that 8 up to 9. So it'd be 0.429. Now we can move down to our percent and say, okay, 0.429. And in this case, we're going to round this to the nearest whole number. So we're still going to move this over 2 places past the decimal. But then we want to look at this number here that is past the decimal, and that's going to help us to round our number. So we know that 9 is greater than 5. So because it's greater than 5, it's actually going to take this number 2 and raise it up. So our percent would be rounded to 43%. Okay. All right, so let's look at another example of this. So in this one, we are looking at the probability, experimental probability at a dance camp. So at a dance camp, students must specialize in one style of dance. Last summer, 46 dancers specialized in ballet, while 52 dancers specialized in other styles. What is the experimental probability that the next student to sign up for camp this summer will specialize in ballet? So thinking about our experimental probability, we're trying to figure out how many students will sign up for to specialize in ballet. And so we have to think about ballet, how many are going to sign up for ballet, and then the total amount that have signed up. And so when we think about our fraction, we think about how many sign up for ballet, which was in this case, if we look at our question, we can say that 46 dancers specialized in ballet. And so that would be the number that we would include in the numerator. And then the denominator would be the total, which in this case, we don't have a total listed. Okay, we have a total of 46 dancers specializing in ballet and 52 dancers specializing in other styles. So it doesn't tell us a total amount. And so we need to take that 46 and add it to 52 to get our total amount, which would leave us at 46 over 98. Okay. So sometimes these questions you have to kind of like read a little bit um, deeply into it to understand if it's saying the total amount or if it's asking you to find the total amount. Then what we can do is we can reduce this. And so if we divide both the numerator and the denominator by 2, that is going to leave us with a simplified fraction of 23 over 49. Now as a decimal, we would convert this the same way we did before. We're going to take that numerator 23 and divide by the denominator of 49. But we, of course, know that 49 can't go into 23, so that's where we are going to add our decimal and add a couple zeros here. And then we think about how many times does 49 go into 230? Okay, and we can say that's going to be 4 times. And then 4 times 49 would give us an answer of 196. And this would leave us with a remainder of 340. Well, I'm sorry, 34. Let me back up. 34, and then we would have to bring down our 0. Okay, bring down our 0. Now we have 340. So how many times does 49 go into 340? We can say that's 6 times, and then 6 times 49 would give us 29. It would give us 294, sorry. So we'd subtract, and this would leave us with 46. Bring down our 0. How many times is 49 going to 460? And we would say that would be 9 times. 9 times 49 is 441. We'd be left with 19. So clearly in this case, we're going to keep going, but we want to look at this as a decimal. So we've got 0.469. We'd add this at the end to let us know that we would keep going. Okay. All right. And then what we can do, we're rounding this to the nearest percent, nearest whole number. Okay. So we have to take that decimal that we have and move it over 2 places. But we also have to look at this number, and that's going to help us to decide what are we going to do with this number in front. And since it is 5 or more, that's going to tell us that we're going to raise that 6 up, and our percent would be 47%. So looking at this, the experimental probability that the next student to sign up for camp this summer to specialize in ballet would either be 23 over 49, would be 0.469, or it would be 47%, approximately 47%. All right, and let's look at one more example of this type with experimental probability. So we're looking at experimental probability. So far this season, Edward scored 9 goals and missed on his 81 other shots on goal. What is the experimental probability that Edward will score a goal on his next shot? So probability of Edward scoring a goal, and we have to think about setting this up as our amount of goals he has made over the total amount of shots that he's taken. So the amount of goals that he made, when we look back at this question, when we go through this question, we can say, okay, he did score 9 goals. And so that's going to be the amount of goals that he has made. And then the total, in this case, this is one of those questions that is not going to tell you the exact number for the total, but it does say that he missed on his 81 other shots. So that means we have to take 9 and add 81 to that. Okay. Usually when you see a question that tells you the total, it's going to say the total amount. So in this case, it says 81 other shots, but we know he made 9 of those shots, or he made 9 separate shots. Okay. And then 81 others he did not make. So that's where we would add those together. Now we end up with 9 over 9 plus 81 is 90. And so in this case, thinking about a number that could go into both 9 and 90, we can divide that by 9. Divide by 9, and that would leave us with 9 divided by 9 is 1, and 90 divided by 9 is 10. Fraction of 1/10. So converting it to a decimal, we're going to take this fraction. We're going to say 1 divided by 10. We know that 10 can't go into 1, so that'll be a 0, and then we need to add our decimal and add some zeros. Bring our decimal up, and then we think about, okay, how many times does 10 go into 10? And that would be 1 time. So 1 times 10 is 10. We'd be left with 0. We really won't need this 0. So our decimal equivalent is 0.1. And then last, we have our percent. So we have 0.1, and we're going to take this decimal and move it over 2 places. The problem is we have this blank, so we have to add a space holder. We would say that this is equal to 10%. So the experimental probability that Edward will score a goal on his next shot is 1 out of 10, or 0.1, or 10%.